Okay, now we want to talk about compounding more than once per year. So, if interest is compounded more than once per year, well, example, let's say we have $1,000 at 12% and we compound it annually. As we've seen, P of t is $1,000 times 1.12 raised to the t. The 1 times 1,000, well, I'm not going to re-explain that. This is something you understand from previously. Okay, now if we compound 4 times annually, that doesn't mean we add 12% 4 times a year. To be fair, we split the 12% up into 4 parts. So we add 1/4 of 12%, which is 3%, but we get to add that every quarter of the year. Well, to do that, we're going to multiply by 1.03, which is what we do if we want to add 3%. We do that 4 times every year. Okay, for 1 year, how much you're going to have? You're going to have your initial $1,000, and you're going to multiply by 1.034 times, which will give you 1.03 to the 4th power. Now that's an advantage, because 1.03 to the 4th power is more than 1.12, so your $1,000 times 1.03 to the 4th is more than $1,000 times 1.12. And to see that that does give you more, just as the first step, if you do 1.03 squared using the binomial theorem or using distributive law, 1 plus 0.03 multiplied by 1 plus 0.03 and use the distributive law, you find that 1.03 squared is 1.0609, which is a little more than 1.06. Not that much more, but it's more. You get a few cents extra, several cents extra, but it'll be in the pennies. On $1,000, it'll be almost $1 at the first compounding. Okay, and then of course 1.03 cubed. Okay, 1.03 to the 4th ends up being more than 1.06. At the end of the year, you're going to have a couple extra bucks, and you can work that out. Take your calculator if you have to, and do 1.03 to the 4th power, and compare that with 1.12. Okay. Okay, well, anyhow, then in t years, that means we're going to multiply by 1.03 how many times? Now stop and think about it. Pause the video and answer this question for yourself. How many times will we multiply by 1.03 in t years? You might think, simpler problem, you break it down to simple. Well, in 2 years, how many times would I do it? Well, then in 3 years. Okay, now I see how many in 2 years. Okay? Okay, well, the answer's simple, and I hope you got it. One time, in 1 year, you multiply by 1.034 times. Geez, in 2 years, you're going to multiply by 1.038 times. Every quarter of every year, you're going to multiply by 1.03, and it's a short step to seeing that you're going to multiply by 1.03 4t times, which means that your principal is going to be what? $1,000 times 1.03 raised to what power? Think that one through. Pause, think it through, make sure you got it before I write it down. But I'm not going to stand around waiting, so hopefully you pause, but that's going to be 4t. Because in t years, you're going to do this 4 times. Every time you do it, you multiply by 1.03 an extra time, obviously, which means you're going to multiply by 1.03 4t times, and there's your principal. Okay. Now, if interest rate is R, and we compound n times annually, then if we start with P naught instead of $1,000, now if you want to write $1,000 there, you can, but you can replace that with P naught to stand for whatever principal you start with, whatever investment you make. What are we going to multiply that by, and how many times? So, think it through. And hopefully you have. We're going to multiply it by, well, 1 plus whatever rate we have, if we're compounding, whatever rate we have to multiply by for every one of the n annual compoundings. Okay? Now here, where we had 12% and n was equal to 4, we divided our 12% by 4, or our interest rate, 0.12, was divided by 4 to give us the 0.03. Similarly, whatever our rate is, we're going to divide it by n. If we're doing it n times annually. So if we do it 12 times annually at 12%, R would be 0.12, and 1/12 of that is 0.01, and we'd have 1 plus 0.01. Now, just as an example, but we want to generalize our example to an expression that we can treat as an exponential function. Okay, well, we get P naught times 1 plus R over n. Now, to what power would we raise this in t years? How many times would we do this in t years? Well, we're doing it n times every year, so it's going to be n times t. Okay? Now, we could compound as many times as we want. We could compound every second. Okay? So you'd have a lot of seconds in a year. Think about 31 million seconds in a year. So you did 1 plus R over about 31 million, multiplied by 31 million times your number of years. Okay? Calculator could handle that. You're not going to want to do that one step at a time. You're not going to want to do 31 million calculations for every year, especially if you got a lot of years. But we want to treat this expression, well, the more times you compound, the less you get for every extra compounding, in a sense. And it turns out that if n gets really, really large, well, this gets really, really large, but this gets really, really small, which means your number is going to be very close to 1. So you're taking a large power of a number very close to 1, it doesn't give you that big a number. Continuous compounding. P of t is the limiting value as n approaches infinity, because if you're compounding continuous, the number of times you compound approaches infinity. Limit as n approaches infinity of P naught times 1 plus 1 R over n raised to the nt. And it turns out that that's equal to P naught times e to the RT, where e is that number I talked about previously. E is the limiting value as n goes to infinity of 1 plus 1 over n raised to the n. And it takes just a little algebra on this expression to see where this expression comes from and why this is then P naught times this thing raised to the RT. And it's approximately equal to 2.71828. And then there's another 1828, which makes it look like it's going to be repeating and therefore a rational number. But it never repeats. It's irrational. Okay, so that's the whole story of compound interest. Now we'll work through a few little algebra details here because it's kind of there's some techniques, a technique that you use to See where this comes from out of this, that applies fairly frequently in mathematical analysis at a higher level.